Besides attributes and methods, classes and their instances can also contain another type of component called events. Instance events can be triggered by the instances of the class, but static events can be triggered by the class itself. Events can also be defined as interface components. Given the right circumstances, handler methods react to the triggering of this event. This means that the runtime system may call these handler methods after the event has been triggered. In other words, the client usually does not call the handler method directly. This results in a completely different modeling concept. While you are developing the class that triggers the event, you do not need to know anything about the class that is handling it. The triggering class sends a specific message to all classes and, if required, their instances. At the time of development, type of handlers and the number of handlers which may be used are not known. Because of the definition of the handler method, the range of possible results can be narrowed down. However, the results which may occur can be determined only after the event has been triggered.
In UML class diagrams, a dotted arrow with the stereotype handles event of points from the handling class to the triggering class. The event definition and signature only appear implicitly in the handling class within the handler method. The handler methods are separated from the other methods using the stereotype event handler.
Depending on the status of your application, you may not need to program every step every time. The separation of cause and effect in your programming should be reflected in the way you construct complex applications. Often, the event is already triggered, and all you have to do is create another event handler. Within a class, instance events are defined using the events statement, while static events are defined using the class events statement. Events can only have exporting parameters, which must be passed by value. A class or instance can trigger an event at runtime using the raise event statement. Both instance events and static events can be triggered in instance methods. You can trigger static events only in static methods. When an event is triggered, the handler methods that are registered to this event are called in sequence. These handler methods can trigger more events of their own.
Instance events or static methods can be defined within a class to handle events. To do so, you must specify the event using the for event statement and the class or interface in which the event was defined using the of statement. If the event contains exporting parameters and you want to be able to address these syntactically, you must have specified the exporting parameters immediately after importing in the definition of the method. The handler method signature exporting parameters are all that are allowed to be included explicitly than the exporting parameters of the associated event. The parameters are typed by the handler method during the definition of the event. The object that triggers the event determines the protocol. In addition to the explicitly defined exporting parameters, the predefined importing parameter, sender, can always be listed. By using that parameter, you can place a reference to the event trigger object into the handler method. Therefore, handler methods are usually called by triggered events raise event. However, they can also be called explicitly call method. The definition of the handler method only specifies how and to which event of which class the method will react. At runtime, it needs to be determined which possible reactions will actually take place and when each of these reactions will happen. When triggering instance events, you also have to specify which event the reaction will trigger. If instance methods are set to carry out the reaction, you also have to specify which instances will perform the reaction. These specifications are collectively known as registration. Registration is always carried out using the trigger. When the event is triggered, the runtime uses the registrations of the trigger to determine which event handler methods need to be called. In this example, handler methods are defined for the event of the vehicle class, the car rental class, and the vehicle registration class. However, you can only predetermine which car rental instances and vehicle registration instances will react to which vehicle instance and when they will do so. Registrations can also be revoked.
Events are registered using the set handler statement. Registration is only active at program runtime. With instance events, for is followed by the reference to the object that triggers the event.
Every object or class that defines events has an internal table known as the handler table. All handler methods that are registered to the various events are listed within the handler table. For instance methods, the handler table also contains references to the registered objects. Hint: objects that are registered for event handling are not deleted by the garbage collector, even if there are no remaining references to them. Note: it is possible to add or remove event handlers for a given event while an event handler for this exact event is executed. If a new event handler is registered, then this event handler is added to the end of the sequence and executed when its time comes. If an existing event handler is deregistered, then this handler is deleted immediately from the event handler method sequence.
Event handler methods can only have the same or more restricted visibility than the events they refer to. Events can be defined as interface components.